Hi everyone. In this video, we are going to understand DNS record types, not only memorizing definitions, but by understanding why each one exists. Okay? Because in real world networking and cybersecurity, nothing exists without a reason. Every DNS record is a solution to your specific problem. Okay? First, why do we even need DNS records? When we use DNS, we usually think domain name, IP address, DNS server. But internally, DNS is not just one record. It is a collection of different record types, each handling a specific responsibility. So the real question is, why do we need so many DNS record types? Let's break it step by step. The first we are going to talk about a record. Okay. Now I put google.com, right? Google.com and press enter. It shows the IP. It opens the website. Okay. Now the system asks, once I put the URL text in URL, it asks what is the IP address of the domain. If then DNS cannot answer this, the website will not open. Okay, now I put another command, abcd.com. It shows an error instead of opening the website because this URL is not exist. That's where the A record comes in. The A record maps domain name and IP address. I use PowerShell here. Okay, and first I open the command. 1 minute. Resolve real DNS name, google.com. So here type what type of record I need. Record A. I type A means A record. Okay. So it gives an output. It gives an output with an IP address of 142.251.221.142. So what it looks like, it is an IP address, or simply we can say it is an IPv4 address. It means 4 octet is there, normally used previously and also now in somewhere. It is IPv4 address. Okay, the type is A. Next, I'm going to explain about another type called AAA. Okay, now I get an address containing IPv6 hexadecimal format like this. Okay, everything. Okay, it is hexadecimal. It means it is IPv6, and the difference between the two, A and 4A, is nothing but it is a 32-bit address. It is 128 because 4 times of A contains 32-bit. 4A contains 4 into 32 leads to 128 bits. Now you understand the IPv6 and IPv4 address. Okay, so this command maps domain into IPv6 address. This command helps to find domain into IPv4 address. It converts domain to IPv6 address. Okay, next one is MX record. MX is nothing but mail server. Okay, so here you can see before explaining this one, now imagine sending an email to somebody like, okay, sending server asks which server handles emails for this domain. If there is no answer, the email fails. That's why we use MX record. It defines which email server receives emails. So who is the authority to handle emails in the email server? Okay, without MX, emails bounce, so there is no email delivery. So MX is responsible for email routing. Okay, here name, query type here, so IPv4. Additional authority I will discuss about, I explain about it later section. So IPv4 and some TP, blah blah blah. Okay. The next thing is I'm going to explain about NX. It's the main part is name server. Think big. Now you think here. The internet needs to know which DNS server is responsible for the domain. Okay. If this missing, the domain becomes invisible. That's why we need use NS or name server records. It defines authoritative DNS server. Okay. Here you can see additional. So here you can see the authority of the domain. Okay. So I give you the differences. Now you understand the differences between the two, right? So, in previous output, you have noticed smtp.google.com or anything else. But here you can see name server ns1, google.com, ns3, ns3, etc., etc. It means without ns, no one knows where to ask. Domain does not resolve globally. Okay. The next one is state of authority, SOA record. So now when we move on to inside DNS servers, we need control and coordination. So the question maybe comes up, what is the current version of zone? When should servers update? And also who is responsible? Okay, that's handled by state of authority or SOA records. It contains primary DNS server, admin email, and serial number. It means version and the TTL and what type of server is, it's a state of authority, everything. Okay, without SOA, DNS synchronization is failed and zone is not available. It means zone becomes unstable. So SOA is the brain of DNS zone. Okay, the next and final is I'm going to explain about this something called text TXT. So here I query with the IP address. Okay, query with the IP address. So the specific server I have mentioned here to get TXT record. So I open here. So this is here you can see google.com and what type of server responses text. TTL time to live, it will how long will stay here, and this section is answer section. The strings is here. So Google's site and DocuSign is SSL, and you can see here one here. Okay, so this output explains about SPF google.com. It means anyone can send using this email. Okay, okay, here you can see verification data, some security rules, means who handles this one, and policies they have written here, and some security rules like DocuSign, etc. So these are I will explain. These are all in our coming videos. So it means without TX, so there is no security. It means it easily we can do spoof attack. So TXT provides security and control policies. Okay, the final one is called PTR. Okay, okay. So okay, now I get. Now you understand that PTR record, trust and reverse lookup. Okay, in our A record we will get forward lookup. So this is the forward lookup from domain name to IP address. So PTR shows the IP address into that domain. Okay, like who is name of the host and TTL, who answer section and name. So everything you can get. That's the difference between PTR and A. A means domain to IP. PTR record is also known as reverse lookup, IP address to domain. Okay, so PTR important for trust and validation. Okay, finally we discussed about DNS records. It helps to solve a specific problem, why it is important, how they are handled in a real environment. Like, so A is for website access, 4A is for supporting IPv6, MX handling email routing, NX domain authority, state of authority, DNS control, TXT for security policies, and PTR explains reverse lookup. Okay, here now we comes to a real scenario question, because just we discussed about the DNS record type. We come here to discuss about that all in a scenario based. The website was migrated to a new server, but users still cannot access it. The key idea is DNS might still be pointing to the old server. Already we discussed that a record maps a domain to an IP address. If the record is outdated, users will keep going to the old server, even if the new one is perfectly fine. Here you can see what DNS could cause it. The record. The answer is um, simple. Update the A record to the new IP. Okay. The second one is, in this case, the website works on some networks but not others, simply mobile, but corporate is not able to access it. That usually confuses beginners. The reason is IPv6. Some networks prefer IPv6 over IPv4. If the AJJ record is misconfigured, those users will hit a broken server. So, if A record is correct, 4A record can silently break things. So, fix or remove this record. Okay. So, what the DNS is explained is broken IPv6, or it may be misconfigured. The next one is canonical name or CNAME scenario. This is a security focused scenario. A subdomain is pointing to the third party service that is no longer used. This creates something called dangling CNAME or canonical name. An attacker can register this service and take control of your subdomain. This is known as subdomain takeover. Okay, it happening due to dangling of canonical name. So always remove unused canonical name or CNAME records. The fourth one is MX record, because already we discussed about this. Yeah, it is for mail servers. Here, emails are not going received after migration. MS records defines where email should go. If they still point to old mail server, emails will fail. This is very common during cold migrations because a lot of companies now moving and migrating to clouds. So I think this scenario will help you to troubleshoot in the basic things. This is very common during cloud migrations. Fix is to update MX record to the new provider. Okay, the next one is TXT as a TXT scenario. The scenario is about email security. Users are receiving spoofed emails from your domain. That means attackers are pretending to be you. This issue is weak and missing SPF record. It tells which servers are allowed to send emails that are mentioned in TXT server. If it is misconfigured, anyone can send email as your domain. So this should be or it must be strict. The next one is service record. This one is common in enterprise environments. Users cannot log into a domain network. That usually means systems cannot find the domain controller. SRV records help locate services like LDAP or Kerberos. If SRV records are missing or broken or login fails. So always check SRV records in Active Directory environment. I will explain about this in upcoming session. Okay.